Hello and welcome to the channel of Sigma Plus Industrial Solutions. In that video, we're going to continue the discussion about the calculation of the sample size for a population where its standard deviation is unknown. In our recent video, we have discussed the calculation of the sample size or the optimized sample size for a population where its standard deviation is known, considering to have a lower possible margin of error with a high level of confidence. Today, we're going to take an example from the food industry where we can calculate the average population with the margin of error and also calculating the sample size corresponding to a certain level of margin of error. Okay, so let's see what the example will tell us. So we want to create a 95% confidence level to estimate the average weight of the hot dog packs in a food production line. So as all of us know that in the food industry, it's periodically important to check the average weight of the food to make sure that they are aligned with the quality specifications. So we have sampled 50 packs of hot dogs and we've obtained the following information. So we have here the sample size of 50 readings of the different weight of the hot dogs and descriptive statistics showing the mean value of 44.12 gram and the sample standard deviation is equal to 3.32 grams. So we want to calculate the average population mean with its margin of error. Okay, so the information that I have is the sample standard deviation, which is 3.32 grams, the sample size, which is equal to 50, and the degree of the freedom, which is the sample size minus 1, or 50 minus 1, which is equal to 49. And here, since that the standard deviation of the population is unknown, we should use the t-score tables. Compared with the last video, where the standard deviation of the population was known, we've used the z-score table. And here the margin of error formula will be different from the z-score. Here the formula of the margin of error will be the t-score to the degree of the freedom multiplied with the s, where s is the sample standard deviation divided by the square root of n, where n is the sample size. So based on the information that I have, I think we're ready now to go to the t-score table and find out what is the value of the t. So this is considered to be a right tail table where the alpha, which is known the confidence, the significant level. And since that our confidence level is 95%, which means that alpha will be equal to 5%. But remember that this is a symmetric distribution. So that's why alpha on the right tail side, it will be equal to 0.025. And from the left side will be equal to 0.025. So what does it mean? It means that when I will go to the table, then I have to take in consideration that to find out the t-score at 2.5%, which is the value of alpha in the right tail side, and 2.5% on the left side. So the t-score is representing the distance between the population mean and the location of the t-score. This is the number of standard deviation between the mean and that point. Okay, so now that's why my second information that I will need to retrieve or to find the t-score value will be the significant value alpha, which is 0.025. So based on that, I can now go to the table and find out what will be my t-score. So by dropping the both line, I will see that my t-score is between the 2.014 and 2.009. And approximately, we can say that t-score will be equal to plus or minus 2 standard deviation. Okay, now we can plot the normal distribution curve for the population average range, where we know that we have assumed at the beginning that the population average is 44.12 gram, which is the sample mean. But now we want to calculate the range of the population means, right? We want to know what will be the minimum and the maximum. Okay, please do not be confused. Maybe because this is actually a z-score, so please ignore this value of the z-score, because now our t-score is found to be +2 and -2, which is the value of the t-score at a significant value of 0.025 and a confidence level and a degree of freedom of 49. Okay, so I think now we are ready to apply the formula for the margin of error and find out what is the value of the margin of error. So the t-score is ±2 multiplied with the standard deviation, which is equal to 3.32 divided by the square root of the sample size, which is equal to 50. And then hence we can see that the margin of error will be equal to ±0.939 grams. What does it mean? It means that my margin of error will be a maximum value of 45 grams and the minimum value is 43.18 grams. Okay, refreshing again, what do we mean the confidence level of 95%? It means that assume that you are going to collect 100 different samples in different time in that period of time. 95 of the samples will have an average value dropping in between the 43.18 grams and 45 grams. And there will be a risk of 5%, which means that only 5 samples might have a population mean dropping outside the range of 43.18 grams to 45.05 grams. And hence, we can also conclude that the margin of error here is ±2% of the population mean. Now, consider that for the same production line, we come later on after 1 month or 2 months or any time, and we want to make further statistical studies, but we want to have to calculate the optimized sample size in such a way that the margin of error will be ±1% instead of the 2.1%. What would be the sample size? We have seen in that example that the sample size that we have taken at the beginning was 50. But in case that I want, for any specific reason, I need to conduct the statistical studies with a lower margin of error. So suppose that we need to calculate the sample size and in such a way that the confidence interval will be no more than ±1 from the population mean. Okay, so again, we are going to calculate, to apply the same formula for the margin of error, but we will set up our equation to be equal to ±1% out of the sample mean or the population mean. Now, in such condition, you should have the standard deviation. So that's why we will refer to the standard deviation of the sample that we have taken from the first time. So if we have now the standard deviation and we have the t-score, okay, so the only unknown parameter will be the sample size. So by just applying all the numbers, 0.01% multiplied with the population mean or the sample mean, which is 44.12, equal to the t-score, which we have found it equal to 2, multiplied with the standard deviation of the sample mean that we have calculated from the first time, which is 3.32 divided by the square root of the sample size. And this the sample size that we need to calculate for taking in consideration that the margin of error will be no more than plus or minus 1% of the population mean. So by doing all the mathematics, we can see that the sample size will be equal to 227. Okay, so what does it mean? It means that whenever you want to reduce the level of the error with a high confidence level, indeed the sample size will increase. The first scenario, the sample size was 50 and the margin of error was plus or minus 2% of the population mean. But here in that scenario, the sample size increased to 227 for the margin of error of plus or minus 1%. Okay, so at the end of the video, I would like to thank you for your good listening and watching, and see you for the next time.